This video is going to show you how to use construction tools, meaning a compass and straight edge, to construct a trapezoid. This is a great way to model for students who are using the actual compass and straight edge. You can use it with dynamic and mimic the same process with them. It's important to use real constructions, compass, straight edge, no measurement, so that students are really applying properties and giving a real understanding to the relationships and the prior knowledge that they need to make these constructions that are precise. So we're going to do a trapezoid. Notice I'm using the inclusive definition of a trapezoid, which means at least one pair of parallel sides, a quadrilateral with at least. The exclusive is exactly one pair. I like the inclusive because it allows you to really explore the hierarchy and see all different types of versions of trapezoids. A square can technically be a trapezoid because it has at least one pair of parallel sides. So it's great conversations to have. We're going to open a geometry sticky, click anywhere, choose geometry. I'm going to turn off auto labeling. So I'm going to go to my settings, click auto, and hit OK. So now it won't automatically label things. When you're doing constructions using precise tools, compass, straight edge, you don't want measurements. So that's part of this. I want a straight edge. So ask students to construct a straight segment line ray. I'm going to use a ray tool. And so it doesn't matter where they do it. They just have constructed a straight edge to start their construction. All right. They use their straight edge. I now want an adjacent side that's not necessarily, that wouldn't be parallel, right? So we're going to use the ray tool again and just make an adjacent side somewhere. It can be in any direction. It doesn't really matter at this point. So let's just kind of leave it there. So I'm going to work with the understanding of prior knowledge that intersecting lines and transversals and how do you construct parallel. I need parallel. Well, we know from the converse of the parallel line theorem that if you have two angles that are corresponding and congruent, the lines are automatically parallel. And so we're going to basically use our understanding of how to create how to construct a congruent angle to another angle to help us make parallel. So here's my one angle for my beginning straight edge, right? So I'm going to get my compass tool, and in this case, I'm just going to use a circle. So ask students to get their compass tool, place the center on the vertex of the angle they have, and make a circle. And it doesn't matter how big or small they make the circle. The key here is that it's intersecting both sides of that angle that they have. So I'm going to make it intersect both angles. I'm actually going to change the color of this as well so that my modeling stands out a little bit. So now notice what I have. Maybe we should change that point as well. I have a compass, a circle that is intersecting my sides of my angle in two places. Maybe I want to actually construct this second intersection. So students would want to also do that on their paper. So now they have intersected their angle sides, one on each side, right? And these are the same distance because, again, this is prior knowledge. All radii of a circle are congruent. So I know that this distance is congruent to this distance. So now what I want is to create an identical circle somewhere else on this side, on this adjacent side, because I'm trying to create a congruent angle to this one. So I want the same process. So with a compass, an actual compass, students would just keep their opening, their radius, the same and go up and construct another circle. In this tool in dynamic geometry ClassPad.net, I want to use a compass, meaning it's going to walk the distance here. So not a circle tool, because the circle tool can change. So I'm going to show you how to use the compass tool. Construct has a compass tool at the bottom, and it asks for you to select a segment which represents the radius or 2 points. And in this case, I have 2 points. My radius is from the vertex of this angle to either this point or this one. It doesn't matter which one I use, so I'm just going to use that one. And notice it creates, and let's actually change the color to red. It creates a second circle, but this circle is different because I can't change its size. It's controlled by the radius of this original. If I change the original, I would change my circle, but that's okay. I want these to be congruent at all times. So now that I have my congruent circle. I'm going to place the center somewhere. It doesn't matter where you do it. It could be really close. I'm going to kind of put it up here so that it stands out. And I'm going to place it on the same side. And I'm going to set it. So I want to make sure it's on that line. So it's on that line, so it's going to stay steady there. What I now have, if you notice, is identical. I have identical circles, congruent circles. They have a point on the side. This is a point on here. This is going to be my vertex of my new angle that I want to be congruent to this one. Well, how do I make it be congruent? Well, I need to look at the distance between this point on one side to the other point on the one side. So I need to measure that using my compass, not true measurement, right? So I'm going to do the same thing. I'm going to create a compass. So let's change our color. And I'm going to go back and get my compass tool. So construct compass. And I'm going to measure the distance between the point on one side of the angle to the point on the other side of the angle. That's our radius, right? And this distance, right? So this distance here is measuring that. And now if I do the exact, and so notice that if I have it at the center of, if I use the center of if I use one of the points as the center and the other one as the radius, I get this intersection. So if I create this exact same green circle here, keeping the distance, my radius, my compass open to that amount, and recreate it up here, I will now have an intersection point that's basically going to mimic this one. So I need to first, let's make sure we put this intersection point that we used as the center up here. So let's construct that intersection right there. And now let's make a copy, a congruent, keeping our compass open. So again, I'm going to go to construct, compass, same opening. So from this point to this, that's my radius. Here's the second congruent circle. And I'm going to place it in the same spot there. And now notice here I have this circle, green circle intersecting this red circle, which we know is the same as this red circle. This green circle is the same as this green circle. So this intersection should be the same. So let's construct that intersection. And now if I connect these 2 points, the center, which matches the vertex down here, to this intersection, which matches this point's intersection here, I should get a second line that is parallel to this first one. So let's just, let's use a ray just for the heck of it. I could use a line, I could use a segment, we're going to use a ray. And so now these two are parallel, and I know that I don't have to measure. In fact, students using compass and straightedge are not measuring. They used properties to verify. So we know that if I construct congruent corresponding angles, lines are parallel. So these are now parallel. And so if I put a point, so let's actually change our color again. Let's change it to purple. I'm going to put a point. I just need a point on this parallel line, right? Oops, let's make sure it's actually on the line. So there's a point on the line. There's a point on the line. And now if you look, I have 4 vertices that are going to be used in my trapezoid. I have this one that's on this parallel line, this one here that changes how my lines move, this original angle vertex, right? And then this point up here that matched this point, right? To guarantee that corresponding. So everything else is just a construct that I use to get to this position. I don't need them anymore. And so I'm going to, oh, that went crazy. I'm going to, I'm not quite sure why it did that. There we go. Here's my point. Okay, sorry about that one, crazy. I'm going to now hide all the constructs I don't want. I just really want to see the 4 vertices so that I can construct my trapezoid. So this is the underlying constructs. Now students, you could just get your polygon tool and follow those 4 vertices, right? So I'm following my 4 vertices, and students would do the same. Here's my trapezoid. So notice that my trapezoid, I can make it be every possible trapezoid as I move it, right? And I can, you know, make it big, small. I could make it be a right trapezoid. I could make it be lots of different things that I explore. This is why I like inclusive definition, because I can make all types of trapezoids. But I don't want to necessarily see all the constructs that helped make it. So maybe I want to hide all of these objects that are not necessary for me anymore. So I'm just going to select the objects that I don't need anymore, like even the underlying lines. And in ClassPad, you can go to Visible and hide the objects, or you can go to Group and it will hide them as a group, which is something I like to do because I'd like to maybe bring them back if students are having, so we'll just call these constructs. And so if I unclick, they all go away. Oops, I forgot one. And so let's just hide that one. Oh, I forgot another one. There we go. So now I have my trapezoid that I can explore. So this is a really nice way to model for students how they're using their own tools, because you're able to use an actual compass and talk about the properties that are going on here. And then once you have it created, you can then explore and actually measure and compare different types of trapezoids. So notice I can create many, all possible types of trapezoids here. And they can see with the inclusive definition that a square could be a trapezoid, a rectangle could be a trapezoid, because the only constraints are it must have at least two sides parallel. It's a really nice way. Now, one thing that is a great conversation when you use tools to construct is if you go all the way to connecting these vertices, it looks like it's a triangle anymore. So you do have to always remind them that it must be a quadrilateral. So even though you can technically make a triangle from your construct in the dynamic tool, that you're really talking about the quadrilateral aspect of things. And also, you can also create a crossover here. Again, this is because of the dynamic tool. And so is this still considered trapezoid? No, because it's not a quadrilateral anymore. So these are some constraints they want to make sure they're always keeping track of, that type of thing. So it's just fun, and I have really messed this up because of the way I crossed it over. There we go. So keeping those things in mind. And then, you could challenge them. How could you, if we change it to the exclusive definition, how could you constrain it so that a rectangle and a square are not a trapezoid? Because you want exactly one pair, not at least one pair. So great conversations to have and really challenging ways to think about this.